Alright, the next thing that we're going to do and work on is simplifying radicals now that have variables, okay? And so your learning target is I can simplify radical expressions that also contain variables. This is a lot like the last lesson. The only difference is that instead of a constant number in the radical, we have some variables in there too. So let's get going. So again, the key concept is a lot the same. The biggest thing that we need to remember about this is that we have to assume that the variable is positive, since square roots cannot have a negative number, okay? So if your square root would be negative, then we wouldn't have a solution. That's why in this type of scenario, we have to go ahead and assume that all the variables must be positive, or they are squared to be a positive number. Okay, so to simplify these types of radicals, the first thing we need to do is, again, find the perfect square. Okay, and that includes the variable. That includes the variable that we have. We want to try to get it to be a square of something. Okay, that's our goal. And so we need to factor the radicand and split the numbers into two different radicals. We need to try to get the numbers that are being factored to be a perfect number, just like we did for constant radicands. Now we factor the variable into as many perfect squares as possible as well. Okay. The second thing then, after you do that, is to simplify it. Just simplify it. Take the square root of the perfect number and the square of the variable. If possible, keep the non-perfect number and variable in jail. If we have non-perfect numbers or non-perfect variables, they have to stay locked up, okay? Let's do some examples. So remember, we talked about yesterday how the radicals right here, the square root thing, that is what is jail, okay? And the numbers, the expression, the radicand, the numbers inside the square root, those are the inmates, right? We're trying to free those that are perfect. We're trying to get the perfect ones out of jail to free up some more space, right? Okay, so the very first thing we need to do is we need to think about what could we split the square root of 75 into in order to get the perfect numbers out. And I know a really good one. The really good one that I know of is 25. 25, we know the square root of 25 is 5. That's one of those perfect numbers. And 25 times 3 is 75. And so we can multiply that by the square root of 3, just like it said in the radical rules, the product rule for radicals. Okay, and then the last thing we need to multiply this by is our r squared. Our r squared. Okay. Now we can go ahead and simplify it, right? The square root of 25 is 5. Times the square root of 3. We can't do anything else with the square root of 3, so that stays as the square root of 3. And finally, the square root of some number being squared is whatever that number is. And so finally, we have this multiplied by r. And so the final thing that we would write on this is 5 times r times the square root of 3. And that is the radical in simplest form. Alright, example number 2 asks us to write this next expression in simplest radical form. And this one's a little bit harder to think of. This one even took me a little bit to try and figure out what was that perfect number we could multiply by. So let's go ahead and rewrite this out. We have this -8, and we're going to multiply that by 1 square root. And what's one of those perfect numbers? So let's try this. Does 4 go into 98? If we do this, 98 divided by 4 doesn't work, right? The next one is 9. We know right away 9 doesn't go into 98. The next one, 4 squared, is 16. 98 divided by 16, that doesn't work. The square root of 5 is, or square root of 25 is 5, but 25 doesn't go into 98. Square root of 36, 98 divided by 36, that doesn't work. And we're running out of options here. The square root of 49, 98 divided by 49. Oh, and we see that one works because that one goes in twice. Okay, 49 is half of what 98 is. And so we can use 49, the square root of 49, as our perfect number, okay? Then we multiply that by the square root of 2 because the square root of 49 times 2 is the same as the square root of 98. And finally, we need to write our variables in squares. So we have b squared, and we're going to multiply it again by b squared again. Because that, b squared times b squared is just b to the fourth, which is what we started with. Okay, now we can simplify this a little bit. We've got negative 8 times the square root of 49, which is 7, times the square root of 2. We can't do anything with that. Times b, because the square root of b squared is just b. Okay, then finally we're solving. Negative 8 times 7 is negative 56. B times b is b squared, multiplied by the square root of 2. And that is now simplified. That is the simplified version of this original radical, okay, right here. All right, we're going to do a little bit more practice the following day. Hope you enjoyed.